Hello student, now I am going to discuss hydrogen and its compounds. It is a very small topic, but the few things I am discussing you have to study like that concept. So, in hydrogen also it is called as a dihydrogen. This is represented by H2. So, that is nothing but a hydrogen. And now hydrogen in a group 1, placed in a group 1, but hydrogen has a similarity with group 1 element as well as group 17 element. We will see over there. Like hydrogen ionization energy. Ionization energy, if you look at for hydrogen atom, ionization energy will be around 1312 kilojoule per mole. Kilojoule per mole hydrogen atom ionization energy if you consider. So, it will be very similar to fluorine. Fluorine around 16 kilojoule per mole. So, that means the similarity is there, whereas sodium ionization energy or lithium ionization energy 452, 400 in that range. So, that means they has a more similarity with the group 17 element rather than group 1 element. Likewise, if I say group 1 element, sodium used to form Na plus and it will combine with the Cl minus, it will form NaCl. Likewise, hydrogen atom also can be formed H plus, which can combine with Cl minus, it can form HCl. This type of similarity and dissimilarity is present. Like hydrogen, like if you look at, like metal, like calcium, whenever the chlorine is combined with this calcium, they used to form what? Calcium chloride. Calcium solid and chlorine gas, when they will react, they will form calcium chloride on combination, theoretical idea. This way they will not form. I am asking the theoretical concept. And now likewise hydrogen can be combined with calcium, it can form calcium hydride. Here the oxidation state of each hydrogen atom will be -1, each chlorine will be -1. That means with the metal hydrogen will be minus, with the metal halogen will be minus, the same oxidation state they will be maintained. Otherwise hydrogen will be +1, or like non-metal hydrogen will be +1 like the metal. So, these different types of similarity and dissimilarities will be present for the group 1 element as well as group 17 element. Now, once you understand this concept, then we have to focus how we can prepare the hydrogens and their reactions and their compounds. These are the things we need to study in these chapters. Preparation is very important. Whenever the zinc is used with dilute H2SO4, not concentrated H2SO4. Dilute H2SO4 you have to take. Concentrated H2SO4 will not react with zinc, will not give the hydrogen. Immediately it will form zinc sulfate, and this, because the idea is the zinc will lose the zinc plus 2 electron will come. From here 2H plus will take the 2 electron will be combined into 2 hydrogen atom. Further they will combine and they will form hydrogen molecule. This is the idea. This is the reactions will be formed over there. These way reactions will be formed. Like sodium metal, if you treat it with water molecule, water means what, my dear? H plus and OH minus. Sodium, what it will do na? Sodium immediately will lose the electron because metal is highly electropositive in nature. Immediately it will lose the electron, and this Na plus and OH minus will combine and they will form the NaOH. They will form NaOH over here itself, and this H plus will accept 1 electron, will be converted to hydrogen atom, 2 hydrogen atom combine, and then they will form the hydrogen gas. So, this way also we can prepare the dihydrogen. You have to understand the logic. Moreover, so for preparations of any metal, if you take highly electropositive metal, so then the reaction will be more faster hydrogen generation. But if less electropositive metal if you take, you have to put the heat. Why? Because the reason is less electropositive metal means they will not lose the electron. When they will not lose the electron, then H plus cannot easily accept the electron and convert it to hydrogen atom. The reaction will be slower. To enhance the reaction, you have to put heat. When you are putting the heat, then the less electropositive metal will be lose the electron faster. Then only H plus can accept the electron and convert it to hydrogen atom, and the 2 hydrogen atom can combine, can form the hydrogen molecule. So, this is the basic idea you have to understand over here. Moreover, few reactions I am mentioning, rather than n number of reaction is there, you can go through, only important reactions I am mentioning. So, now here if you look at another very important reactions is there. If you treated the coke with, coke means carbon, treated with water around 1723 Kelvin temperatures. So immediately we will guess CO plus H2, this is called as a synthesis gas or it is called as a water gas, my dear. This is nothing but what? Water gas or synthesis gas, hydrogen will be liberated. And if you take carbon monoxide, reaction with water molecule in presence of 673 K, in presence of iron chromate, if you react, immediately it will form CO2 plus hydrogen will be comes out in the system. So these are the different way we generate the hydrogen. Even from the electrolysis of water molecule, if you go for the electrolysis, electric spark if you send over here, then H2 will be dissociated into hydrogen. So from here we will get hydrogen and oxygen. So that means this way also we can generate the hydrogen. So these are the possible way for the generations of hydrogen, dihydrogen or hydrogen gas. Once you understand these preparations, few different types of hydrogen we need to know, their reactions we need to know, and then we have to proceed towards that. So then if you understand these simple reactions, then you have to need to know, like hydrogen, there are two types of hydrogen is possible. One is orthohydrogen and one is parahydrogen. What is that ortho and para? Hydrogen molecule means two hydrogen nucleus will be there like that. When their spin will be in a same side, when the nuclear spin of the will be same side, two hydrogen atom, we call it as a orthohydrogen. When the nuclear spin of the two hydrogen atom will be in a different side, one is this direction, one will be this directions. So like that, then we will call it as a what? Parahydrogen. One means same direction. Para means this is going this direction, this is going this direction, two different directions. So that is why this is called as a parahydrogen. And generally at normal temperature, 75% para and 25% ortho will be present. But if temperature is around 20 K, lower temperatures, temperature will be very lower temperature, then 99% there will be para and almost 1% will be there in ortho. That means almost parahydrogen, almost near to 100% parahydrogen possible in a lower temperature, but reverse is not true. But what is the difference between ortho and para? Parahydrogen will be more thermal conductivity will be there, but orthohydrogen is a less thermal conductivity will be there. These are the only difference, but the chemical reaction, both hydrogen will be the same. So these are the things, important things you need to know. Once you understand orthohydrogen and parahydrogen, what are the different types of hydrogen is there? So isotopes, you know 1H1, this is nothing but a normal hydrogen. 1H2, this is called as a deuterium, represented by D, deuterium. And then 1H3, this is called as a tritium, this is represented as a T. So these are the different isotopes. Already I discussed what is isotope. Same atomic number, different mass number due to different number of neutron is called as a isotopes. Here electron is 1, proton is 1, neutron is 0. In deuterium, electron is 1, proton is 1, neutron is 1. And in tritium, electron is 1, proton is 1, neutron is 2. So that is the things you have to understand over here itself. So this is nothing but the isotopes of hydrogen. Once you understand isotope, orthohydrogen, parahydrogen, some reactions of hydrogen. We have to see some reactions of hydrogen. What is that? Let us focus on some reactions of hydrogen. What is the reactions of hydrogen? Let us focus that one. Reactions of hydrogen. Already you know reactions of hydrogen. Reactions of hydrogen. Among the reactivity, when you consider hydrogen atom has a more reactivity compared to nascent hydrogen. Compared to hydrogen molecules. This is a reactivity order. So then if you look at hydrogen atom means its lifespan is 0.3 second, hydrogen atom. Lifespan will be 0.3 second. Nascent hydrogen means whenever from the reaction directly the hydrogen is coming out, that is called as a nascent hydrogen. So just produced hydrogen atom, that is called as a nascent hydrogen. So hydrogen atom reactivity will be more compared to nascent hydrogen. nascent hydrogen is greater than hydrogen molecule. Already we know hydrogenation reaction. If you take the alkene, if you treat it with hydrogen with nickel, hydrogenation reaction you know, this is a syn additions, this hydrogen will add over here, already you know these reactions my dear. So this is one of the reactions of hydrogen. Suppose with the metal, if you take calcium hydrogen, then immediately it will form calcium hydride. Already you know these reactions my dear, very simple reaction. Hydrogen plus F2 is nothing but a HF. Hydrogen plus Cl2 is nothing but a HCl. So these are the things you have to understand. These are the reactions you have to understand. So these are the very reaction. Vegetable oil plus H2Ni, immediately you will get vegetable fat or ghee. Vegetable fat, nothing but a vegetable ghee, you will get it over here. So these are the different reactions of the chemical reactions of hydrogen you have to understand. N number is there, only few things which are really important, I am focusing that things. So we study what are the different types of hydrogen, then hydrogen means similarity, dissimilarity, then chemical reactivity we discussed, then the different types of compound of hydrogen. The first I am entering is nothing but the water molecule and then heavy water. Then heavy water, after that hydrogen peroxide. We have to proceed. Hydrogen peroxide I will do in a separate class, but the H2O and D2O I will explain over here. After that, the last class I will explain the hydrogen peroxide. So then if you look at the main molecules of hydrogen is a water. Now this water molecule, first very important thing you need to know, water is nothing but a universal solvent. Universal solvent, it is called as a universal solvent. It has a n number of uses. All type of solvent we use the water molecule. It has a humorous example because the life starts from water itself. So that is why it's a very important thing. So then in the water, first we need to know what is hard water, what is soft water. So already you know what is hard water my dear student, hard water, and then we need to know what is soft water. Soft water. These things we need to know. So that is why in the hard water, if you put the soap, the lather or the cloth will not be created easily. Why? The soap is nothing but a, the soap will be nothing but a sodium or potassium stearate. Sodium or potassium salt of a stearic acid. This is a sodium stearate or the sodium stearate. Sodium stearate or potassium stearate. That means the sodium salt of a stearic acid or palmitic acid. This is a soap. And then hard water means there will be lather will not produced easily. Lather not produced easily. Why? The reason is generally you will see in Chennai also there will be lot of in the water salt will be there, different types of salt will be there because of the closeness of the sea. So that means you will see after washing the hand with the soap that you will feel that your hand still it is like a lubricated. It will not go, the soap will not go very easily, you will feel that type of experience because of this hardness of water. Moreover, more type of cloth will not come. Why? Because in the hard water there will be calcium or magnesium, that chloride, sulphide or bicarbonate salt will be present. The calcium, magnesium, chloride, sulphide or bicarbonate salt will be present, which will create the hardness of the water. So that is why the lather will not be produced. Why? Whereas in a soft water, lather is easily produced. That means when you will put the soap, lather will be easily produced. That means the cloth will be easily produced. So why these things is happening? Now you will see, and then how we can remove this hardness of water, that we have to focus. So then for that, if you look at in this case, what will happen? Suppose I am telling you that whenever the soap is there, like nothing but a hard water we are taking, and then soap is there, 17H35 C minus Na. Suppose in the salt there is a calcium chloride is there. So that means calcium chloride salt of a calcium is producing hardness. Immediately they will react with this and then they will form C7H35CO whole 2 Ca. With that 2 NaCl, like that things will be appear. Like that the zinc will be appear. Because of these formations, they will not allow to produce the froth. This is the reaction will happen. So that is why whenever any salt, calcium or magnesium salt or chloride salt or sulfate salt or bicarbonate salt will be there, they will be produced like these things. Because of that, and then the calcium stearate will be formed or magnesium stearate will be formed. Because of that, there will be froth will be not generated easily. So this phenomena will happen. Then how we can remove the hardness of water? And then what are the different types of hardness? One is a temporary hardness. Temporary hardness. Temporary hardness. What is temporary hardness? The temporary hardness is nothing but that, so which will be created by bicarbonate salt, bicarbonate salt of HCO3 means bicarbonate salt of calcium or magnesium, which will produce the temporary hardness. And then permanent hardness will be produced by chloride or sulfite salt of calcium or magnesium. And then temporary hardness can be removed by different method. What is that method? We will see that things. First of all, hardness why is created we know. Then there are two type of hardness is there: temporary hardness, permanent hardness. Temporary hardness created by bicarbonate salt of calcium and magnesium. Permanent hardness is created by chloride and sulfate salt of a calcium and magnesium. And then how we can remove this temporary hardness and the permanent hardness, let us focus on that. So then once we understand this, how hardness is created in a water and how we can remove this temporary hardness and permanent hardness from the hard water. So then let us focus that one. Temporary hardness will be created by the bicarbonate salt of a calcium and magnesium. So that is what here, removal of temporary hardness. Removal of temporary hardness. In temporary hardness, how we can remove this temporary hardness? So then removal of temporary hardness, what we will do? We will take the bicarbonate HCO3 minus and then we will say CaHCO3 whole 2, this calcium bicarbonate. And if I heated this compound, simply immediately we will get calcium carbonate and then H2O and carbon dioxide will come into the picture. This calcium carbonate will be precipitated out. That means this way we can remove the temporary hardness. With that carbon dioxide will come over there. Got the point? So that means temporary hardness can be removed by simple heating. Again, temporary hardness can be removed by addition of a slag lime. Calcium hydroxide is called as a slag lime. So then when we will react these things, here also that calcium carbonate will be precipitated out and the hardness will be removed. And this process is called as a Clark's process. Clark's process will be employed to remove the temporary hardness. 2 years questions came from here, Clark's process. This Clark's process is employed to remove the temporary hardness. So these things you have to understand. So these are the temporary hardness can be removed by this way. Then permanent hardness, how we can remove? Let us focus. The permanent hardness, removal of permanent hardness. Removal of permanent hardness. Removal of permanent hardness. In permanent hardness, how you can remove this permanent hardness? The permanent hardness can be removed very easiest way, like you have a calcium chloride salt which is creating the hardness. If you add the washing soda, Na2CO3, then immediately calcium carbonate will be precipitated out. You can separate, with that NaCl will be formed. So that means permanent hardness can be removed by some desired amount of adding the sodium carbonate, which is called as a washing soda. Like that permuted method, you have a calcium chloride salt or calcium sulfate salt. If you treated with permuted. Permuted is nothing but a N4, P4, N6, P4, O10, P4, N6, P6 and O6. This is nothing but a permutate. And permutate here, from here itself, out of the 6 sodium, 2 sodium ion will be removed, and then immediately you will get N4 and then O6 and P6. Like that, N4 and O4 and P4. Like that compound will be there. And then permutate actually is represented by like this, Na2Z. That is sodium hexametaphosphate. So this will be sodium hexametaphosphate. Like that they will be present. This is a permutate. And then whenever this calcium will come into this picture with this permutate, so then what will happen? Instead of Z is nothing but a hexametaphosphate. So then this calcium will exchange this with this and sodium will come over here. Immediately it will form calcium permutate plus that NaCl will be formed, and then immediately Z is a hexametaphosphate. So that is why these will be removed by this one. This is nothing but a permutate. And this way we can remove the permanent hardness. Another method is there. Suppose calcium chloride is there, you are adding zeolite. Zeolite is nothing but a sodium aluminous silicate. Sodium aluminous silicate. Now you look at in place of sodium. So overall charge if you calculate, oxygen 4 into -2, and then silicon will be +4, and then aluminium will be +3, and then sodium will be +1. These are the overall charge. 3 plus 1, 4 plus 4, plus 8, 4 into -2, -8. So these are the total system. Now if you remove one sodium, then this AlSiO4 overall will be how much? Minus charge will be there overall. So then immediately when this calcium chloride will be react with this is nothing but a zeolite or also permutate, whatever you call it. So then immediately this calcium will replace this one, this sodium. Then immediately we will get calcium AlSiO4 whole 2. So then immediately this type of compound will be formed, and then the hardness of water will be removed. These are the nothing but the permanent method to removal of hardness. Another one important method is there, that is nothing but a ion exchange method. What is that? That is nothing but a ion exchange method. So if you look at this ion exchange method, they used to exchange the cation or anion. Suppose they will take like this RH, or they will take RNA, either with if this R is the sulfate, or there will be long hydrocarbon will be there, with that SO3H group will be there, which will be replaced with sodium. Now this RNA, when you will treat it with CaCl2, so then immediately we will get R2CA, this type of exchange will happen. That means the cation, this is a resin, which was there as a sodium salt of a resin, that will be exchanged by the calcium, that is the cation exchange is possible. When you will treat with NaCl again, then you can regenerate the resin. This way they can regenerate the resin, and that is nothing but an ion exchange method. The resin has a sodium cation which is exchanged with the calcium ion from which is creating the hardness of the water. And now another one we can get, we can remove with like this, like that amine is there. That means resin is there in amine form. It will take one protonations, and then immediately it will form RNH3 plus. This will act as a cation, and now this cation, this way also it can get exchange. So that means instead of NH3 plus, so there are some exchange, the cation can be exchanged. Suppose if you have some anionic exchange, if you have a ROH minus, so that ROH, this is nothing but anion, or this will be anion. First it will take the proton and this will go away. Instead of that, anion also can come. So that means the cation also exchange is possible and the anion exchange is possible. Both way that the removal is possible. You have to understand these things. So that means what are the way we can remove the permanent hardness? One is Na2CA3, one is permuted or zeolite, one is cation exchange resin. So this way we can remove the hardness of the water. So that means water, once we understand, then the hardness can be measured by what? That is nothing but a ppm, parts per million. So that means already I discussed during the concentration term the parts per million, that means the whatever amount will be there, that the calcium or the magnesium salt in per million to create the hardness, that is nothing but a parts per million. So that way also we can do these things. Once you understand this water molecule, then this water molecule can use to form the different types of hydrogen bond. What is that? Is nothing but whenever it is there in a liquid form, it will form the hydrogen bond like this. So this one of the water molecule, this will make a hydrogen bond with the another water molecule like this. They will form like the continuous structure like that one. But whenever this is in a liquid form, but whenever they are in a ice form, the one water molecule is making a cage-like structure. This will be one hydrogen bond will be like this, and from here also this will be like one hydrogen will be like this, and from here also this will be like this, from here also here will be like this, and then this will be like this, and this will be like this. One cage-like structure will be formed. Cage-like structure will be formed. Cage-like structure, because of formation, lot of void space will be there inside the ice. So that is why the density of the ice will be less. So that is what you have to understand. And this way you need to know the water molecule. When you understand the water molecule, then you need to know another thing is nothing but a D2O. D2O is nothing but a deuterium. When it's combining with oxygen, we used to got the D2O. This is nothing but a heavy water. Only few things you need to know regarding the heavy water. Where is the use of a heavy water? As a nuclear reactor, D2O has a lot of uses. Moreover, the isotopic study can be done using this D2O. That means the any isotopic exchange, like the hydrogen you need to exchange with the deuterium, and you need to study the kinetic effect, isotope kinetic effect. That time we can put this D2O. So these are the different uses and the preparations and the method, types of water molecule we discuss. The next class I will discuss regarding the H2O2, how we can prepare the H2O2, and then we will proceed for the reactions of H2O2, and then we will proceed for the strength of H2O2, how you can determine, and then only this hydrogen chapter will be completed. I hope you understand, my dear student. Thank you everyone. Thank you all.